Hi, so this is the fifth and final lab for Physics 2211. So for this lab I chose to do a demonstration of the properties of rotational motion. The following equations are used to model the position of a point on the radius, the momentum, and the torque. A quarter, a penny, and a nickel will be used to show how differing masses and radii affect the calculated values. Each coin will be spun on its edge and tracked over one full rotation. Angular velocity, or little omega, is delta theta over delta t. Momentum is L, or mvr, which is moment of inertia times omega, and moment of inertia in this case is 1/4 mr to the second. And torque in this case is radius times force times sine theta. So constants in this case were the quarter's mass, which was 5.67 grams, and its radius, which was 12.13 millimeters. The penny's mass, which was 2.5 grams and had a radius of 9.525 millimeters. The nickel's mass was 5 grams, and the nickel's radius was 10.605 millimeters. So predictions: the quarter will have the highest angular momentum, L, as it has the highest mass and largest radius, both factors in the moment of inertia, I, all other things being equal in this case. So here's the quarter video. As you can see, it spun off rather quickly. Nickel, here's the nickel video. I tried to apply close to the same amount of force to each of them as possible, though it's impossible to truly measure that out in this case. And here's the third and final video of the penny, which had the smallest radius and smallest mass. As you can see, the penny fell rather quickly, so it had very low momentum. Here are the graphs of the X and Y position over time. For the quarter, as it quickly spread out of the frame, you don't see much of a trend, just that Y is rapidly decreasing as X is increasing as it moved off to the side. For the nickel, you see a more sinusoidal graph, which you would expect from a rotating or oscillating object, because it would go off into a pattern, then return back to a spot, and then go back off into that pattern. And the penny, for as short as the video was, actually was fairly similar in nature as a sinusoidal graph. So the conclusions we had were: the nickel had the most stable momentum, as the sine and cosine of the point along the edge oscillated but followed a repeated pattern. The quarter had angular momentum equals 0.00567 times 0.0123 times 2 over 100, which was roughly the linear velocity in meters per second, which is 0.0000138 kilogram meters per second, which is extremely low, but much higher than the following two. The nickel had L equals 0.005 times 0.010605 times 1.4 over 100, and the result was a angular momentum of 0.00000074 kilogram meters per second. And the penny had L equals 0.0025 times 0.00925 times 1.7 over 100. It was actually spinning slightly faster than the nickel, and its momentum was 0.000004 kilograms per meter second. So each one is roughly half of the coin above it. And as predicted, the quarter had the highest angular momentum, and because it was spun counterclockwise, that is in the positive z hat direction.